that is exogenetic processes, which is part of geomorphology. When we talked about vagina, when we talked about seafloor spreading, and we also spoke about plate tectonics, we were actually focusing on the endogenetic factors, that is, which is happening from inside the earth. So processes which were actually affecting things from inside the earth was discussed in this. But now we will be seeing what are the processes which are acting on the earth's surface. Something like you take rivers. Rivers flow on the surface of the earth. When rivers flow, we understand that they carry some sediments along with it and they deposit them. So, rivers also change the landforms which are present on the surface of the earth. For example, when we saw folding, faulting, all these associated mainly because of the movement of the liquid magma present in the mantle. But when we consider the exogenetic processes, even these bring some changes on the surface of the earth, either locally or regionally, based on the extent of their movement. And these landforms are also important for our study from geomorphology point of view. Because these exogenetic processes also create certain landforms, it is important mainly because if we have to understand where people will stay, why certain civilizations will start at a particular place, which place is good for agriculture, which soil type is good for agriculture, all these we can understand only when we read the exogenetic processes which are acting on the surface of the earth. And as we know, the major source for its movement is actually brought by the energy received from the sun. If you have to see rivers, that is also associated with the rainfall, which is in turn associated with the energy. And if you see air blowing to form wind, wind action is possible mainly because of the energy received from the sun. And when you see the sea waves action, then it is also dependent upon this. Only if you consider the groundwater movements, initially some part is dependent on the sun's energy. Rest is mainly through the chemical processes that act. So if you see major exogenetic forces are actually driven by the solar energy. So let us see some of these processes in detail. And remember, you get most of the questions from this in prelims only. You will not get many questions from mains point of view. In prelims, almost all types of questions come, mainly related to the terminologies. In this chapter, we will come across a lot of terms. And the main problem with this chapter, especially for students when they read any other book apart from NCERT, then they will see a lot of pictures, minute details is being given, and UPSC will never ask you such questions. Only for geography optionals, we have to read each and every landform in detail. So whatever I'll be covering here will be more than enough. I have taken most of the lecture from the NCERT directly. When I take NCERT, I'll tell you those chapters you may not read at all. So, with all these, let us begin with the exogenetic processes that we are actually talking about. So, what are these exogenetic processes and how they actually function? So, if you see, you have endogenetic processes where you see activities happening inside the earth. You have diastropism. We have seen completely epirogenetic, orogenetic. You have volcanism, earthquake, all these are associated with endogenetic processes. You have extraterrestrial, that is meteorites when they fall on the earth, they create certain landforms. Even this is important, but very minimum you have knowledge about this. So UPSC will not ask you any questions regarding this. Third, you have the exogenetic processes. That is, first you have gradation. That is aggradation. If you take Great Plains of India, that is your Ganga plains, they are actually formed by the sedimentary deposits which they carry after eroding the Himalayas. It is not only Ganga, along with Ganga, the tributaries also which flow carry sediments with it and they deposit it. When these sediments are deposited, they usually form alluvial soil. So that sedimentation process is known as aggradation. Second, you have degradation, where we are actually talking about erosion of the rock surfaces, mainly because of the erosional agents like river, wind and all. Whenever river flows on a rock or on a hill, say for example for hundreds of years, then they start removing the sand particle now and then. And we know that there are different types of rocks. Some are hard rocks which the rivers cannot erode. But there are some soft rocks also. This river's winds can actually erode. When I say erode, it can break it into pieces, and these larger pieces in turn become smaller ones. So all these are possible with these soft rocks. Hard rocks may be still present, but soft rocks will be eroded. Over a period of time, even this hard rock, if it is hanging like this, and you have soft rock below, then if you keep eroding this soft rock, even this hard rock will fall because of gravity. So we will be seeing all such processes. Here we are talking about degradation, which may be chemical degradation also, physical degradation also, and biological degradation also. Then you have weathering processes. That is, when a rock is actually placed at a particular point for a significant period of time, then that rock will also break into pieces, mainly because of the rainfall and the heat energy which it receives from the sun. You might have observed that if you have any iron rods, some rocks which are associated with it, if it is kept in a disclosed place for, say, example, 1 year or so, you will see that lot of crystals will be present below it, because that rock or that iron rod rust it would have released. These rust are the crystals which have come from these rocks, will form soils in the natural regions. And if you see, Earth was formed some million years ago. At that point of time, only rocks were present. After a particular point of time, due to the activities of the sunlight and also due to rainfall which came much later, had led to disintegration of these rocks to form small particles called soils. Then we talk about mass wasting. If you have some rocks being present on the top of the hill, then if you have river water flowing or if you have rainfall happening, at that point of time the water will carry some amount of rock debris along with it downstairs. So if the rock debris which is present on the top will flow down with the slope, right? With the slope, if it comes, it is mainly because of the gravity, where it may be moved because of wind or anything, but most importantly it will be because of the gravity, that is the steepness that is being generated. So that is what you will see in mass wasting. Then you have erosion. Erosion can be through running water, rivers, groundwater also through solution, that is, it reacts with the minerals that is actually present, eroded and form different structures. Then you have sea waves. Whenever waves come and hit, you see certain sediments being actually generated because of the sea wave action. Then you have winds. Even glaciers, wherever they are present, they create certain landforms based on their flow. Then you have aggradation, that is gradation itself. Then you have work of organisms. Different terminologies we have seen. Let me go in detail and let me take one after the other and help you in understanding from UPSC point of view, because this, if you're reading from geography point of view, especially optional point of view, every terminology has its own theories. I don't want to get into those complexities and make this chapter much more complex. In a simple way, I'm going to tell you what is important and what is not with the help of the pictures. First, let us see denudation or degradation. When we say denudation, it is also equal to degradation. What does it mean? Weathering at that place, if the rocks are getting disintegrated or if they break into small pieces. Mass wasting, they are being transported due to gravity, or mass movement is one and the same. Erosion, you are eroding it, you are transporting it and depositing, usually leads to general lowering of the land surface. So if you have a hill like this, so over a period of time this hill becomes like this, and this entire region will be eroded. So this is what we call general lowering of the land. I'll show you pics which has changed. Or rearrange landforms based on climatic factors, slope and lithology. That is, based on the climate, based on the slope and lithology, you usually, that is the rock structures that are actually present, you usually observe that the landforms, if you have mountains, if you have waterfalls, they reduce into plains. So this process is known as denudation or degradation. You may get a term in UPSC related to this, so please be careful. Then you have these processes act slowly in the hot, arid and lowlands. If you take lowlands in the sense which are actually plains kind, so if you take this, here the processes will act slowly. If it is hot and arid conditions where river waters are less or underground waters or glaciers are less, then you usually observe that they act slowly. But if you take cold, humid, cold means in polar areas, humid rainfall areas and glaciarized uplands, that is, you have mountains, plateaus and all, there the action will be quick, mainly because of the presence of rivers and glaciers. See, wind will remove little, rivers will remove more, right? So that is what they are actually trying to say here. In arid regions it is less because wind is the main source. In humid and cold, as glaciers and rivers erode major resources, we call it to be quicker. Then you have the next important concept, that is base level. Before I enter into the actual thing, as we have seen, we always look into the basics. So base level is important for us. When we are actually talking about base level, what do you understand by it? See, if a river is flowing, right? River will flow and erode only if there is a slope, right? Once you have a horizontal plane, will the river flow for longer period? It may flow not straightly, but it may flow in a sinus way, right? In this shape. Till which place? So first you have slope, steep, gentle, horizontal, then it will flow only till it reaches some potholes like structures. It will flow only till some basin like structures. Naturally, the basins are your sea level. So once river flows into sea, then river will not flow outside. It will not come out of the sea and again it will not start flowing. So once river flows till sea level, erosion can also be seen only till the sea level. Below this you will not see much erosion. So deposition and erosion will occur only till the base level. Locally, if you are not talking about the sea level, if you take some lakes, for example Caspian Sea and all, which are actually the lakes. If you see you have some lakes, then rivers will come and flow into the lakes. Again, it will not come out and flow as rivers. So only if it is filled, then the stream may flow in a different direction. But you usually observe that rivers flow into locally produced lakes. And once if they enter into lakes, it is done. So base level is the minimum level below which the rivers do not flow or they won't erode. So this is usually sea level. Locally, it may be lakes, dams, etc. Right? So this we should be knowing. So let us see what it is. John Wesley Powell, to ease the understanding of exogenetic processes, introduced the term base level. It is the theoretical level below which erosional processes of agents, especially of river ends. That is, below this, river do not erode. The ultimate base level is sea level, but if the river encounters hard rocks, it may be above sea level, and locally if there are lakes below sea level, then the base level will be lake. So, base level means below which erosion does not happen. So, if there is a question in prelims, base level is only sea level. There cannot be base level below sea level. If this statement is given, it is wrong. Mainly because if you have lakes which are below, then the base level will be those lakes. See, can you see here? So from the reservoir till the reservoir, all the rivers will come and stay. Once it gets accumulated here, it acts as the local base level. But again, when the dams are opened, the rivers will start flowing and they reach the sea level. Below this, they cannot erode. So this is what we call the ultimate base level. And this dam is actually your intermediate or artificial. Local term is important because it is only present on that area. Local base level. But this base level is not static. It may rise or emerge and fall or subside with endogenetic processes acting from below. We have seen diastropism. We know that earlier you had Tethys Sea when we were actually talking about the plate tectonics, where we spoke that you had Pangaea, Panthalessa. Pangaea was actually divided into Angara land and Gondwana land. In between that you got Tethys Sea. Now what happens? All the rivers which flow, they may enter into the Tethys Sea. Right? Rivers whichever will flow, they will enter into the Tethys Sea. After a particular point of time, when the Gondwana land, especially the Indo-Australian plate, when it merges with the Eurasian plate, you got Himalayan mountains. Right? We have also seen this. Now, initially, you had Tethys Sea. So, sea is the base level. After that, you got mountains. So, due to this, what happened? You got rivers flowing from above. So, here the base level was stopped and the entire rivers rejuvenated. That is, again the river cycle started. Initially, from where the river flows, that is the topmost portion, and when the river actually joins the sea, that is called as the mouth of the river. Okay, so if you actually consider this, mouth of the river was Tethys Sea. But as Himalayas was formed, you will usually observe that the mouth of the river got rejuvenated and it became the initial stage. So usually in river, you have different stages. It is called youth stage, mature stage and old stage. As you see in human beings, even in rivers, we have these three distinctions: youth, mature and old stage. So if in the beginning, that is where the river actually comes, in that stage we usually call it to be youth stage. And if you have certain structures, like if the erosion by the rivers is more, then we usually call it to be youth stage. When Tethys Sea was present, the rivers were in its old stage. But again, when Himalayas was formed, these rivers rejuvenated and they went back to their youth stage. Mainly because once Himalayas was formed, we observed that these rivers started eroding these stuffs. I will talk about the different stages of the rivers. Youth, mature and old within another half an hour. That is not an issue. But my point here is you should understand that there are different cycles in the river life also. There are different theories associated with this, but for GS geography that is not required. That is why I'm not going in detail. But remember, as you have different stages, rivers, whenever they see some sort of endogenetic factors coming up, then they get rejuvenated, and if they are in old stage, they will reach to mature stage, or they may reach to youth stage directly, as we see in the Himalayan rivers. Or if there is glaciation, then usually what happens, the sea level reduces, then the old stage will become mature stage. So all these are some of the common processes which are associated with the river flow. So what I want you to know is, base level will not be constant because of the endogenetic forces acting from below. The base level may either increase or decrease. When the base level increases, that is, if the sea level increases, then if you are in the youth stage, you enter into old stage directly. But if it decreases, if you are in the old stage, you enter into youth stage quickly. This I will talk when I talk about the youth, mature and old stages also. But remember, whenever I speak about this, understand it carefully because questions may come from this. So for example, Himalayan upheaval, this we saw. If sea surface goes down or if land emerges, it is positive movement because a new cycle will start. I told you, if river is in its old stage, the cycle is already end. You are going to die. But if it comes to the youth stage, new cycle will actually start. So we call it positive movement. If sea surface rises or if land surface submerges, then it is called negative movement because the cycle of erosion stops. Have these two, you will get assertion and reasoning type of question, or UPSC may give statement 1 and statement 2 and confuse you here and ask you which statement is correct. These two lines will give you question for sure. So please try to understand it carefully. Once I begin with the youth, mature and old stage, it is easy for you to understand this in detail further there. Next, let's see which are the factors which control erosion and weathering. First is the climate. What does it mean? Precipitation, temperature and wind. If you have more rainfall, rivers and all get more water, so their activity will be more. High temperature, then you have pressure differences, movement of winds and also of water will be more. Wind will also affect movement of these waves, rivers, even the wind itself can be an erosional agent. Then you have topography, that is your altitude and relief. So if the relief is steep, then it is different. If it is gentle, then the topography and the impact will be different. Rock structure, that is whether they have joints or not, whether they are crystallized, chemically reactive, or if it is soft or hard. All these will help us in understanding whether it is erodible or not. Time is the most important factor. With time, things keep changing. So factors which affect, you will not see small changes. Usually erosion and weathering are long-term changes. Weathering, let's begin with the most important process. Processes acting at or near Earth's surface to cause physical disruption, which we call mechanical also, and chemical decomposition of the rocks. We call this weathering only if it is happening at in situ. That is, Weathering is the first stage of denudation which affects the rock in situ. That is, wherever the rock is present, there only disintegration of the rocks will take place. Say you have a rock and it is left for hundreds of years, and after that if you go and see, that rock will be degraded into small pieces, and in turn this will be eroded into small ones. So weathering, where we call there is physical or mechanical disruption or chemical decomposition of the rock in the place where it is present. It is not transported. So if it is actually present and it is eroded in that place itself, it is degraded in that place itself. I will avoid the term erosion as much as possible because that is associated with another phenomena completely. So understand, we are talking about degradation, decomposition at the same place. So if that happens, then we call it to be weathering. Remember, the major difference between weathering and erosion is weathering happens at that place. So if the rocks break and if the sand is present there, we call it weathering. If it moves, then we call it different names. So weathering is the first stage of denudation, that is degradation, which affects the rocks in situ, in the place where it is present, and no transportation involved. This is the major difference between erosion and weathering. Now tell me, if I talk about the soils that are actually formed due to weathering, then will the parent rock, that is the soil which is formed from the parent rock, will it be same or will it be different? So if parent rock is present below and soil is actually present above. So if the question is, in weathering process, the soil which is formed, will it be closer to the parent rock or will it be different from the parent rock? If transportation of the soils are there, then it is different. As weathering do not have transportation, then the soils and the parent rocks properties are one and the same. So this is important. Next, weathering is important to produce soils because large rock is broken down into smaller particles. You have three types of weathering. First is your physical weathering, mechanical weathering. Second, chemical weathering, where there should be some chemical reaction taking place. Third, biological weathering, either human beings or organisms which are present, or trees which help in breaking of the rocks, is called as biological weathering. So first let us see physical weathering. If you see this rock, right? This rock is broken here mainly because of the heat. So whenever you have sun rays heating the rock also expands because the air which is present may expand, or if you have the water molecules present in the rock, even they are expanded. So whenever they expand, then you usually see breaks. If you take temple architectures in India, especially the South Indian temple architectures, you see that the rocks that are actually used are hard rocks. And if you see the cuts and all, they are very much proper. How is it possible for you to have long and heavy rocks being cut? How can you cut these rocks? At that point of time, what they used to do, wherever they had these joints and little bit fractures that are actually present, these are the weakest portion within the rock. So if you take this rock, this will be the weakest portion. These things will be harder to break. So now what they do, they usually grind or make a small hole there, and they used to keep wood pieces in. In alternating rainy period and summer season and winter season, they used to observe that there will be expansion and contraction of these wood pieces. And whenever this used to happen, then the rock used to break automatically. This is how large boulders of rocks were broken. And this is your physical weathering which they had observed, is what most of the people usually say. We don't know how far it is true, but we understand that when you have a rock piece, due to sun rays and precipitation, you usually see that there will be cracks happening over a period of time. They break into pieces. This further break into pieces and form small soil particles. When rock is broken and disintegrated without any chemical reaction, because if you have chemical reaction, you usually call it to be chemical weathering. So this is without chemical reaction. In this, you have different types. The first type is your frost action. What does it mean? It is found in cold climates, that is in your tundra region or polar regions, or it can be seen in the Himalayas, temperate region. Water expands as much as 9% of its volume as it freezes. So if you have water filled in the rocks, it expands 9% of its volume as it freezes. Freeze thaw, that is, it will freeze and again it will become water. It will freeze, expand, again it will become water. Action leads to mechanical breaking of rocks in different shapes. See this? So water seeps first into this. It goes much deeper. And it expands 9% when it is cooled in different climatic conditions. When it expands, it is broken. So this is your freeze thaw action. Try to remember the pics rather than just mugging up the terminologies. Then you have crystallization. It occurs in arid and semi-arid region. Please remember, frost action is seen in the cold climates. Frost, freeze. It will happen only in the cold. You will not see water becoming ice in tropical region or arid region. In tropical region, in summer, what happens? Water will become water vapor. Due to that, the dissolved crystals which are actually present in the water will get evaporated, and these crystals get accumulated and they create disintegration. So in the first, it is due to cold temperature. Second, it is due to arid and semi-arid climates. As the water evaporates, crystals form from dissolved minerals. These crystals over a period of time accumulate and enlarge and break. So they get accumulated, they get enlarged and they break into smaller pieces. So let's see the pic. These are actually seen due to crystallization effect.